My two 300 PRC rifle builds are done, and both of these rifles shoot awesome. Gavin Gear here from UltimateReloader.com. This has been a great learning process and just a ton of fun from start to finish. If you haven't already, you're going to want to check out the videos that chronicle this full custom 300 PRC build. This has got an MDT ACC chassis, a Kelbley's Atlas Tactical, custom long action, benchmark barrel steel, Trigger Tech diamond trigger. This thing is loaded to the gills with custom features. This is going to be probably a $5,000 to $7,000 rifle once you factor in an optic and once you factor in a gunsmith building this gun for you. Then we have the subject of this video, part 2 of the budget 300 PRC rifle build and rifle rebarrel. This started out as a Remington 700 long range chambered in 300 Remington Ultra Mag. Now, a lot of you have been complaining about my use of the word budget. That's not a budget rifle. Well, the word budget is like the word precision, like the word match grade. Completely subjective. This rifle would cost approximately half of what this rifle would cost. A more budget-oriented second focal plane optic, a much more budget-oriented starting build list, very similar benchmark barrel steel. What's interesting here is I've got a 1 9.5 twist barrel, which was Benchmark's recommendation for the 300 PRC, and I've got a 1 8.5 twist barrel, which was the Hornady and prescriptive guidance for building a 300 PRC rifle. Now I've just broken in the budget-oriented rifle, and I'll go over the results at the end of this video, but so far things are looking really promising. In the last video, I did an action truing job. We looked at things like truing the action threads. We trued up the face of the receiver and the lug seats. We lapped the lugs. We trued up the bolt face and things of that nature. And that pretty much can put a Remington 700 factory action into the same class operationally in terms of precision as a custom action. You're still not going to get a lot of the really nice custom features, but you can certainly build a rifle that shoots lights out with a Remington 700 factory action. So I also upgraded some other things. I've got a Badger Ordnance 312 thousandths inch thick recoil lug that is massive in comparison to the factory recoil lug that came with this long range model. I did some work on the Bell & Carlson M40 stock. I added an Accurate Mag bottom metal and detachable box magazine setup here. And in this video, what I wanted to do was go through the machining and chambering of the rifle, the clearancing, inletting, and bedding of the stock, and talk about how this rifle came together as a package, share some of the results from the range. So let's get started with the barrel work. So before I get into the barrel work, I've got a couple Precision Matthews machines here that I use as a part of these builds, and I used as a part of this build. I've got the Precision Matthews PM 1440 GT lathe. This is the only Taiwanese lathe that's available with a short spindle with 2-inch through spindle capacity. I've got an entire video on that. And then I have the Precision Matthews PM 949 TV Bridgeport clone. 9x49 mil, lots of room to work on stocks, as you'll see later when I talk about the inletting and clearancing. It's variable speed, 3 horsepower head. Absolutely love that machine. And I have DROs on both, which are becoming essentials absolutely in my shop. So the barrel work starts with a plan, and the plan that I have followed follows the work that Gordy Gritters and Fred Zeglin have put together in their Chambering Rifles for Accuracy series. Fred talks about hunting rifles, and Gordy talks more about things like bench rest and ultra precision rifles. And then I've also got all of the notes from the precision rifle building school that I took at the Extreme Accuracy Institute, that school that Gordy Gritters puts on. So that's the general process. I've kind of fine-tuned that for some of my needs. I also create a build manila folder and put all of my notes in this folder. I put my build sheet in that folder. I'll print out prints from the manufacturer if I've got something like a custom action. Did that for the Kelbley's Atlas tactical build. And that way, if I ever have questions or ever want to refer to anything that I did for that particular build, I've got a whole set of notes that I can refer to. So what I want to do is basically walk through my notes, and we'll talk about the process that I followed chambering this barrel. And there's a lot of these videos I've done, a lot of videos to come. I'm going to highlight something a little bit different each time. So the build starts by confirming the measurement of the barrel. This is a 26-inch finished length benchmark, button rifled, 5 land, 5 groove, barrel blank for 26-inch finished length. And that means the blank is going to be somewhere around 27 inches. So I took about 1 inch of the breech end and cut that off on the metal cutting bandsaw. I then carefully installed the barrel blank in the lathe. I'm using a 4-jaw chuck with aluminum pads on the spindle side, and then on the outbore side I have that special spider that I made that has a single pinch clamp that clamps onto the outside of the spindle, and I can manipulate the 4 spider screws to adjust the angle of the barrel. I start with a rough dial. I just get a 1,000th indicator out, go on the outside of the barrel blank. Yes, that's not the most accurate method, but it doesn't need to be at this point. Get it within a total indicator reading of about 1,000th of an inch. Face the breech end of the barrel blank because I've got those bandsaw marks. You can also part that off on the lathe, but for simplicity and for speed, I like to do it on the bandsaw. Sometimes I'll part off the muzzle end on the lathe. It all depends on my mood. So once it's faced, we can then pre-drill. And this time I got a little bit more aggressive on the pre-drill compared to, say, when I did the full custom build. Gordy's recommendation is to take basically the shoulder diameter, the larger portion of that, subtract about 30 thousandths of an inch, and pre-drill to within about 0.1 to 0.2 inches, depending on how much taper you have and other factors of where that shoulder is in your chamber. So I eked my way up closer to that, this time with my pre-drill, then moved to the fine indicating of the barrel. This is where you're aligning the barrel, that critical throat section of the barrel, to within 1 to 2 10,000ths of an inch total indicator reading. And my method is the same as most cases where I'm dialing something in. I use the jaws of the chuck for the radial measurement, and then I use the outboard end, whatever that is, for the angular adjustment. And I run the indicator in and out until both of them agree. And it's an incremental process. Start radially, then angular, radial, angular, radial, angular, until both ends that you're indicating from, for me it's on either end of where that throat area of the chamber is going to be, are indicating at about 1/10,000th of an inch total indicator reading. It's all about where you want that reference to be and where you're dialing in. At this point, the pre-drill can be cleaned up with a boring bar to get that section running absolutely, totally true. And what I'm looking for there is there's going to be some surface roughness inside there where the boring bar did the pass. So typically I'll see a little bit of a twitching of that 1,000th indicator. You're at about 1 to 2 10,000ths total indicator reading, but you're carefully looking for chatter and movement of the boring bar. So when that's completely dialed in, then it's time to basically turn down the outside of the tenon. And this is where I'm going to spotlight on the DRO. A DRO on a lathe is not absolutely necessary. In fact, when I took Gordy's class, he didn't have a DRO set up on the lathe that he was using at the time. He's since got a PM 1440 GT of his own, and he got the DRO with that. So that's awesome. With a lathe, the DRO is a super nice to have. With the mill, 3-axis is, I think, an absolute necessity for precision work. But what I like to do when I'm turning down the tenon and I'm using the DRO is I'll get the cutter up against the very end of the tenon and I'll zero out the Z. The Z is the lateral motion of the carriage on the ways of the lathe. And then I'll take one pass, taking off about 0.1 of an inch or so, move the cutter back without moving the compound or the cross slide, and then take a careful measurement with a micrometer. This is a 0.100 micrometer here. And what you're going to do is then take that number and input that value for X, which corresponds to your diameter. You can either go for radius or diameter on your DRO. I have it set up for diameter. And you just type that value in and then make successive passes. When I get within about 0.1 of an inch of the finished diameter of whatever I'm turning, I'll then check it again and adjust that X value. This is what's great about having a DRO, is you always know where your diameter is going to be at. And you always know where your carriage is going to be at. If you're stopping on a shoulder, if you're cutting to a certain depth, whatever it is you're doing, you can very quickly determine where you are with respect to those cuts that you're making. And in this particular case, I took the 1 1/16 OD of the tenon and I increased that 0.2 of an inch. That's because I took off about 0.2 of an inch when I trued up those receiver threads. So as a reference, I wanted to be 2,000 over. Did that really matter? No, but it gives me a visual reference when I'm cutting those threads to know when I need to start checking with the 3-wire method or by screwing on the receiver, whatever it is that I'm doing. And after you thread enough times, you'll get a sense when you see the peaks of the threads getting narrower and narrower, the tops, you know that you're approaching that value. And what you'll notice is they'll get relatively sharp when they're at the appropriate depth. So this time what I did is I took multiple passes at the threads. I cut the threads down to where I felt like they were going to be relatively close, and then I started screwing on the receiver. And initially it wouldn't thread on, then it would thread on a couple threads, and as I got down to the appropriate depth, it would work its way all the way. I don't like to run them super tight, the thread tolerances, so I like to, when the receiver is screwed all the way on up against the recoil lug, to have just the slightest of rattle. And this can help your threads not gall when you're taking your barrel out and reinstalling it, that kind of thing. So this is what I call the incremental direct fit method, where you've got a reference item that's internally threaded, you're externally threading, and you're just going to check till you get the appropriate fit by feel. Threads will center themselves, so it doesn't have to be super, super, super tight in order for things to run concentric with each other once you, for instance, install the barrel. So that's my highlight, turning the OD of the tenon and the tenon length using the 2-axis DRO, and in this case, threading for a specific diameter. A bunch of different ways that you can do this. There's no one right way to do that, but that worked out really well. I just had to take a few extra minutes to run a few extra passes there. The other thing that I did at this point, once the threads were on, was to time the barrel to the action. And this is where, on the outboard end, you're indicating off of the grooves so that as you've indicated the barrel, the outboard end is not going to be exactly concentric with the muzzle end. There's going to be a little bit of run out. And what you want to do is run that run out up so that the barrel is pointing up, and then clock the action as it screws onto the barrel so that the barrel will be pointing up once it's tightened down. So what you want to do is run that receiver onto the threads and figure out where it needs to be to not be quite vertical, but when it's tightened, you can anticipate how much crush there's going to be and how much movement there's going to be, and to have it pointing up. This is going to give you a little bit of extra elevation at long range, and 300 PRC is definitely one of those cartridges where that's a bit of an advantage. And to make that adjustment, you turn down the shoulder. That's the easiest way I've found to do it. And you adjust that shoulder just right until the receiver clocks just where you want it. Here's where I made a little bit of a mistake. It wasn't a big deal. I started chambering, and I'm chambering along, and then all of a sudden I realized when I was going to check with the bolt, I didn't have a counterbore yet. I don't know if I was still on autopilot mode from this Kelbley's Atlas Tactical, which uses a flat front bolt and doesn't require a counterbore in the barrel. I don't know what was going on for me, but I switched over to a boring bar and made very careful passes to cut that counterbore. So I've developed a technique for cutting the counterbore that works really well. And that's to use a boring bar, and to get that boring bar up against the end of the tenon, zero the DRO on the Z-axis, cut to the appropriate depth, taking off about 0.010 of an inch from the inner diameter and stopping 5 thousandths short of the appropriate depth. Withdrawing the tool, take digital calipers to determine the inside diameter that was just cut. It's plenty accurate when you have 8 thousandths of clearance for the bolt nose. And then setting the x-axis of the DRO to that value. It's just like what I was just talking about with cutting the OD of the tenon. Then taking successive cuts, still stopping 5 thousandths short on the depth until the inside diameter is about 5 thousandths shy of the finished diameter. And then to take one continuous cut pass at the depth with the saddle locked down for a nice finish with that boring bar. And when the appropriate diameter is achieved, then to unlock the carriage and make a really, really fine cut along the Z-axis to bring that diameter to the proper spec. If you do it right, you can end up with a really nice cut along the depth and along the inside diameter, the bore of the counterbore. And you end up with a really nice perfect radius that's equal to the radius of your tool. I'm using indexable tooling, so that's the profile that it will give there. And it just looks really good. So with the counterbore cut, I was ready to continue chambering. And my goal here was to end up with chambers that are nearly identical between the two rifles. Because I'm going to be fireforming brass, I'm going to be performing precision reloading techniques, annealing, precision bumping of the shoulder, and I'd like to have the ammunition be completely interchangeable. And since the chamber geometry is with the same reamer, that's a great goal. I'll get to that in just a moment. So I took successive passes. I'm taking off 200 thousandths at the beginning. There's not a whole lot of cutting that's going on initially with that pre-bore, the bulk removal of the chamber material. And then I decreased to 100 thousandths of an inch plunge per pass, each time wiping off the reamer and blowing off out the chamber and swabbing it as well. You want to get all the chips out of the way so you don't get a chip caught on the reamer flute, and that could cause some scoring. Here I'm using the same Dave Manson reamer that I used on the full custom. I'm using Dave Manson bushings. It's a piloted reamer so I can fit it to the barrel blank. And I'm also using Dave Manson go and no-go gauges. Great stuff. Worked really, really well for me. And then there's the moment when you're working up to that last couple thousandths of an inch of chamber depth. And this time I'm doing the same technique that I did with the 300 PRC full custom. And that's basically to get the receiver screwed on with the recoil lug in place and a go gauge with 2 thousandths of Scotch tape on the back of it. So you're lengthening it 2 thousandths of an inch. And cutting the depth so that the handle just closes on the go gauge with the 2 thousandths extra. Then hopefully when you tighten the action down, it's going to take you to 0 if you have approximately 2 thousandths of an inch of crush. So I finished very, very carefully. I removed the barrel from the lathe. I then flipped it around, reinstalled it in the lathe, and cut my standard threaded muzzle. This was originally taken from the dimensions from the Ruger Precision Rifle, cutting the OD to .625, threading at 5/8, 24, and then cutting it to length. And there's a couple specific things that I do in addition to that. I cut a small step down where the end of the threads are so that you can get whatever muzzle accessory it is, whether it be a brake or a suppressor, located And then the threads start behind that, and it creates a condition where these muzzle accessories will spin on really smoothly. Then I cut a flat recessed crown. At this time I did something just a little bit different by using a solid carbide boring bar, the same one that I used to bar out the insides of muzzle brakes to get the appropriate diameter. And that actually put a really nice, clean cut on that recessed crown. Really crisp edges of the rifling. I checked it with the patch, didn't get any fuzz going through, so that worked out really well. The barrel was then removed from the lathe, and the receiver was threaded onto the barrel. I've got the Brownell's barrel vise fixture here. This is an 1.25" shank, so I put the appropriate bushings in there with some powdered rosin for a bit of extra grip, and put some moly grease on the threads, slid on the Badger Ordnance recoil lug, and I've got a Wheeler Engineering Remington 700 action wrench that I custom fit to the Badger Ordnance recoil lug profile when I did my 224 Valkyrie. That was why I went with this Badger Ordnance recoil lug again. Super beefy, great product, very reasonably priced, and I knew I had the profile accounted for here. And what that does is it just makes the installation and the alignment of the recoil lug and the receiver very consistent. I knew I needed that because of the bedding job I was going to do, which I'll get to in just a moment. So I tightened the action on to approximately 100 foot-pounds of torque and checked the headspace. And the headspace ended up just where it was with the full custom. With the Go Gauge Plus 2000s, no bolt action, no handle drop. Without the tape, with just the Go Gauge alone, the handle would drop to very near to the bottom and then just slight resistance to take it to the bottom. So I'm just on that absolute minimum spec based on the Go Gauge. That's where I wanted to be, and I wanted it to be super consistent. I have checked, and I have 2 pieces of the full custom once fired brass here, and I have 2 pieces of once fired brass from the budget build, and these measure the same with the Hornady Headspace comparator kit. That is great. That means my ammunition is interchangeable, my fire-formed brass is identical. Mission accomplished. Absolutely love it. Then it was time to take on all of the stock work and the bedding. It seems like every time I put together a custom rifle, whether it be from off-the-shelf components or based on a factory rifle, there's always a bunch of fitting work that I need to do on the machines. And I think that's where the true value of an experienced gunsmith comes into play. This build was actually similar to the 6.5 PRC lightweight build that I just did. You're going to want to check out that video if you haven't already. In that, we've got kind of a sporter profile stock, and there's inletting that has to happen and there's fitting that has to happen. So before I took on the bedding, there were a couple things that had to happen to just get this rifle to come together in terms of a good, solid, dry fit. The first was additional clearancing in the barrel channel, because as you can see here, if I hold these barrels next to each other, there's a pronounced step down here transition on the factory barrel that this M40 style stock was profiled for, and it's actually quite thin compared to the MTU profile barrel that was going in its place. So I took my familiar high-speed steel spade bit. This is just a wood spade bit that I made into a round profile. It happened to be just the right diameter, probably because I used it for that 6.5 PRC build for a very similar setup. And I aligned the stock very carefully in the PM949 TV, and I took multiple passes, increasing the depth incrementally until I was down to where the barrel channel pretty much matched the aluminum inletting, right where the action sits and the recoil lug sits back against. That gave the stock a really nice even appearance, and the cutter just cut right through the fiberglass. It took off the surface coating, and it actually went through the swivel stud, the steel end of the swivel stud. I went nice and slow over that. And when I fit the action with barreled action into the stock that way, I could tell my clearancing was really good. So I rounded the edges slightly. Later I gave that a coat of black paint, some just matte finish spray paint, to seal the surface of the open pores of all of that fiberglass, so that if gun oil gets down there or who knows what, it's not going to impregnate into the stock. So that's just a little bit of a finishing touch. I also had clearancing work to do in various other places of the inletting on the stock. I noticed that the Elfman Tactical 700 SA trigger was hitting the front of the trigger well in the bottom metal, this Accurate Mag bottom metal. So I clearanced that quite a bit. I'm noticing that with these Remington 700 drop-in monolithic triggers, quite often the front profile is a lot longer and it requires clearancing. I had to do that on the MDT ACC for the Trigger Tech Diamonds trigger. It's just, it underscores the need to have this kind of equipment around. If you don't have a mill and don't have a lathe, you might want to think about getting one if this is the kind of work that you want to do. And then I also found that the bottom metal needed a little bit more relief up towards that front bedding block area. So I increased the overall dimensions of the magwell area in the stock to accommodate the bottom metal until it would snap into place. At this point, my dry fit was looking good, and it was time to take on the epoxy bedding. I'm using Marine Tex epoxy. It's been working really, really well for me, so I used that on this project as well. I taped off the parts of the receiver that I didn't want to get epoxy on, which was primarily the front of the recoil lug and the upper parts. I decided, since this is a tapered recoil lug and I've got a heavy 30 cal Magnum going on here, to leave the sides of the recoil bare so that they would bed into the epoxy and lock in when you tighten that front action screw. If the recoil lug sides aren't tapered, you can't do that because it'll get really, really bound up. Another reason why I like this Badger Ordnance recoil lug. So I mixed up some epoxy. Here was my mistake. I did not mix up enough. If I learned anything from Gordy's class in the bedding section, it was more is better within reason. If you skimp out on your epoxy, you're going to have voids and you're going to be doing it again, and that's what I did. I did a first pass, I let it cure for a day, I broke the action out of the stock, and I noticed some voids in some areas that needed just a little bit of attention. So I did another pass, and I just kind of filled in those areas with a little bit of extra and pulled the action out of the stock, and it looked really, really good. Not 100%, but really good. 100% functionally, just cosmetically, a couple tiny minuscule voids. Not a big deal, not something that I'm going to worry about this time. So when I assembled the rifle in the stock, I did the check, which is basically to get both action screws very lightly torqued, and then to work the torque on the front action screw, holding the barrel and the fore end of the stock to feel for any movement. No movement. Absolutely love it. So I installed the scope rail. This is an Evolution Gunworks 20 MOA scope rail, and I put the scope back on and checked out how the rifle was going to feed. Now these mags go in nice. This is, you know, AICS style mag, and everything was working pretty well, but I do have a little bit of tuning to do, because what I'm noticing is the front has to kick up, which kicks the back down, and then the bolt slides across the back there. So it will feed. It's slightly problematic. So for the break-in, I was single feeding, and I'm going to tweak the lips of the magazine ever so slightly to hopefully prevent some of that tipping. Maybe adjust the height of the mag in the mag well just a little bit. Typical stuff that you have to do. I had to do that with the ACC. I had to get a longer magazine catch to get that mag up a little bit higher. And this has been a really reliable feeder. So at this point, the only other thing I did was to make a timing shim for the muzzle brake. The muzzle brake is timed. I cut the back of it to clock perfectly on the full custom 300 PRC. And for the budget build rifle, it was, of course, clocked wrong, as you would expect. So I cut a shim, I think it was 44 thousandths of an inch thick, and that gave me just the right amount of tightening torque to bring it into perfect alignment with the rest of the rifle. So now I've got the Silencer Co. Omega 300. I can run the Omega 300 on both rifles. I also have the Silencer Co. Hybrid I can run on either rifle, and I can run the brake on either rifle. It's great for comparison purposes. The only other thing left to do was to break in the barrel. And the barrel break-in went really well, but what I found was, compared to shooting this 26-pound rifle, this more budget-oriented 300 PRC felt like a bucking bronco. This is a 300 cal Magnum. It's like shooting a 300 Win Mag plus a little bit. The full custom weighs in at 26 pounds, ready to rock. This budget-oriented rifle is about 14.5 pounds, ready to rock. That includes the bipod, it includes the muzzle brake and everything. So the full custom is not quite double the weight, but it's significantly heavier. And that helps so much when it comes to keeping the rifle steady and having repeatable recoil reactions each time you fire the rifle. So what I found was I experimented with putting my fortune cookie bag on the front and having the forend ride in that sandbag and crushing it down. I got it kind of shimmed up with some wood, and then putting a leather bag in the back and trying different things with that rear bag, but basically letting it sit in the bag in the front. Compared to the bipod, that brought the group sizes way, way, way down. And it's something I'm going to experiment with further. I'm not used to shooting 30 cal Magnums all the time, so it's been a bit of a new experience in terms of getting the proper setup in place and refining my shooting technique, which is all about practice and experimentation. I'm going to be building a concrete bench, and I've got a Sinclair International bench rest style front rest, and I'm going to be working on the entire setup to get more of the shooter out of the equation when it comes to just evaluating the rifle. But having said that, in the barrel break-in, I went through my standard procedure of 1 shot clean, 1 shot clean, 1 shot clean, 3 shot clean, 3 shot clean, 3 shot clean, 3 shot clean. And in that process, I had one of the 3 shot groups down at exactly 0.5 MOA, just over a ½ inch group for 3 shots. And so I feel like when I get this dialed in, and that was with factory ammunition, that was with Hornady matched 225 grain ELDM ammunition. I feel confident that this rifle will be half MOA, probably less, when I get the shooting arrangement completely dialed in and with a bit more practice and trigger time. The Elfman tactical trigger helps tremendously. The X-Mark Pro trigger that came with the rifle would not allow me to have the same level of concentration with this heavy recoiling rifle. So I really like that setup, and I really like the Trigger Tech Diamond on the full custom. So that pretty much concludes this 2-part build story. Like I said, if you haven't seen the action truing video, that's totally new content for the channel. You're going to want to check that out. It turned out really well. The rifle shoots awesome. The fit and finish now is great. The bedding job turned out superb. And I believe once I get these magazine issues fine-tuned, it's going to be awesome. So what's next? I've got a lot going on with the PRC series. It's all about shooting now and load development. The Ultimate Reloader Ranch, the snow has been melting. I'm going to get everything all set up, and we're We're going to compare these two rifles to see how the 1 9.5 twist compares with the 1 8.5 twist, and see what kind of results we get shooting off the bench, and then of course go to really, really long ranges. Just got a whole bunch of steel set up with Seth Gardner from DM Targets. If you're looking for steel targets, check out d-mtargets.com. Lots of really good stuff happening. So I hope that you will subscribe with notifications, because you're not going to want to miss that action. Do you have a 300 PRC? Do you have thoughts about the budget 300 PRC or the full custom PRC? Drop a comment and let's start a discussion. If you liked the video, please give it a thumbs up. Don't forget, I'm on Patreon. I got a full article write-up, that first link in the video description. I've got Ultimate Reloader shirts at the Ultimate Reloader store. Until next time, happy shooting and happy reloading.